In the high desert of northern New Mexico, a persistent auditory phantom haunts the edges of perception. For decades, a small fraction of residents and visitors in the town of Taos have reported a relentless, low-frequency sound, often compared to a distant diesel engine idling just out of sight. This auditory anomaly, which became widely known in the early 1990s, does not behave like a conventional noise. It permeates the quietest hours of the night, penetrating walls and earplugs with equal ease, creating an inescapable sensory experience for those attuned to it. For the individuals who can hear it, the phenomenon is far more than a mere curiosity. The continuous drone often leads to severe sleep deprivation, chronic headaches, and a profound sense of isolation, as the majority of their neighbors experience only absolute silence in the exact same environment. The stark divide between the affected minority, roughly 2% of the local population, and the unaffected majority immediately complicated early efforts to understand the situation. When complaints reached a critical mass, it became clear that subjective experience alone could not solve a puzzle that left no obvious physical trace. In 1993, the sheer volume of distress calls prompted an unprecedented response from the federal government, drawing the attention of Congress. A formal investigative team was assembled, pulling elite scientists from the nearby Los Alamos National Laboratory, Sandia National Laboratories, and the University of New Mexico. This multidisciplinary task force deployed highly sensitive acoustic measuring equipment directly into the homes of the most severely affected individuals. Their goal was to isolate the specific frequency of the sound, which sufferers generally described as hovering somewhere between 30 and 80 hertz, hoping to trace its origins to a definitive physical source within the local environment. The results of this rigorous acoustic sweep were entirely unexpected, confounding the seasoned physicists on the team. Despite utilizing sophisticated instrumentation capable of detecting the faintest environmental vibrations, the microphones failed to register any unusual low-frequency acoustic signals that correlated with the reported hum. This lack of physical evidence forced researchers to systematically eliminate the most obvious external culprits. Industrial machinery, distant mining operations, and the low-level acoustic emissions of electrical power lines were all ruled out, as none produced signatures matching the specific complaints of the residents. With external acoustic sources eliminated, the investigation pivoted inward, prompting medical professionals to explore the possibility of a physiological phenomenon. Audiologists began to examine the individuals who reported the sound, testing for common inner ear conditions that might generate internal noise. The prevailing medical hypothesis centered on tinnitus, a well-documented condition where damage to the auditory system causes a ringing or buzzing sensation. However, comprehensive hearing tests revealed that the affected individuals in New Mexico did not exhibit the typical auditory profiles or hearing loss patterns associated with classic tinnitus. Furthermore, objective tinnitus, a rare variant where a doctor can actually hear the sound emanating from a patient's ear using a highly sensitive microphone, was definitively ruled out. Researchers also tested for otoacoustic emissions, a phenomenon where the inner ear itself generates faint sounds, but the results were entirely negative. The biological theory also struggled to explain a crucial detail. The sound often ceased entirely when sufferers traveled far away from the Taos region. The failure of standard audiology to provide a neat answer suggested that the anomaly might not originate in the mechanical structures of the ear itself. Researchers began to hypothesize a heightened sensitivity to everyday background noise, perhaps amplified by complex neurological feedback loops within the brain's auditory processing centers. As the biological inquiry stalled, geophysicists offered an entirely different paradigm, shifting the focus to deep seismic activity. The Earth itself is never truly silent, constantly vibrating with low-frequency energy generated by massive geological and atmospheric forces operating on a planetary scale. One compelling geological source involves microseisms, continuous faint tremors caused by the relentless pounding of ocean waves against the continental shelves. These deep, rhythmic vibrations generate Rayleigh waves that travel through the Earth's crust for thousands of miles and can theoretically be transmitted upward into the foundations of structures far inland. The challenge with the microseism theory lies in the established threshold of human perception. While highly sensitive seismographs easily record these planetary vibrations, there is no known biological mechanism that explains how a human being could perceive such subtle tectonic movements as an audible, irritating drone in the air. To bridge this gap, scientists explored the concept of acoustic coupling. This theory suggests that under highly specific architectural conditions, the low-frequency vibrations from the Earth could resonate within the enclosed space of a house, effectively turning a bedroom into a giant acoustic guitar body that amplifies the inaudible into the audible. Yet, even the acoustic coupling theory fell short when tested against the rigorous data collected by the Los Alamos team. If houses were acting as resonance chambers for seismic activity, the sensitive microphones placed inside those homes should have easily detected the amplified sound waves, but the recordings remained stubbornly flat. Another avenue of exploration moved away from acoustics entirely, focusing instead on electromagnetic energy, specifically very low-frequency radio waves. These specific frequencies are utilized heavily by the military for communicating with submerged submarines, as the long waves can penetrate deep into the earth and ocean. While VLF waves are pervasive across the globe, the human body is generally considered oblivious to this type of electromagnetic radiation. However, some researchers proposed that under specific, highly unusual conditions, these fields might interact directly with human neural tissue. This concept draws parallels to the Frey effect, a documented phenomenon where certain microwave frequencies can induce the perception of clicking sounds directly inside the human head. While the frequencies differ, the underlying principle suggests that electromagnetic fields could bypass the eardrum entirely, creating a perceived sound directly within the auditory cortex. Proving this electromagnetic hypothesis remains extraordinarily difficult, as isolating individuals from all background VLF radiation to test their perception requires specialized Faraday cages and controlled environments that are hard to replicate in the field. The lack of definitive experimental proof leaves the electromagnetic theory as a tantalizing yet unverified possibility. The localized mystery in the American Southwest is not an isolated incident in the broader annals of auditory anomalies. Similar, persistent, localized hums have been documented in places like Bristol in the United Kingdom and Kokomo, Indiana, each spawning its own intensive scientific and civic investigations. In the Kokomo case, investigators actually succeeded in identifying a physical source, a pair of massive industrial cooling fans at a local manufacturing plant that were emitting a specific low-frequency tone. The community felt a sense of relief, assuming the mystery had been definitively solved. However, the resolution in Indiana only deepened the broader scientific puzzle. Even after the factory modified its equipment to silence the fans and eliminate the measured acoustic frequency, a subset of residents continued to report hearing the exact same agonizing drone, completely unaffected by the mechanical fix. This recurring pattern across different continents suggests a profound complexity at the intersection of environmental acoustics and human neurobiology. It implies that what we classify as a single, unified phenomenon might actually be a multifaceted convergence of different physical stimuli and psychological sensitivities. Some contemporary researchers suggest that the hum may be a modern byproduct of our increasingly noisy world, a form of sensory overload. In this view, the constant barrage of low-level mechanical noise in modern society might recalibrate the brain's internal noise floor, causing it to generate a phantom sound when placed in a genuinely quiet environment like the high desert. The enduring enigma lies in the extreme selectivity of the experience, regardless of whether the source is external or internal. Science has yet to map the precise biological, genetic, or environmental variables that perfectly align to turn a silent landscape into a deafening, inescapable drone for just a tiny fraction of the population. The Taos hum remains a compelling frontier in the ongoing study of human perception and environmental interaction. It stands as a testament to the fact that our understanding of the sensory world is still evolving, reminding us that the deepest mysteries are sometimes not hidden in the stars, but echoing quietly within our own minds.